Hello, this is problem number 11 on the 5-2 homework. And we're given this following table of probabilities. We're asked, is this a probability model, right? Um, one thing we're just looking for is to make sure these are all between 0 and 1, and that the total of the different probabilities adds up to be 1. So yeah, the rules for the required probability model are met. Now we just are asked to calculate in part B, what's the probability that a randomly selected murder resulted from a rifle or shotgun? It's a real cheery problem. Um, so here's my work for this one. Okay, so the probability of rifle or of a murder being committed by a rifle or a shotgun, um, we can just use the general form of this, where it's for any or probability, it's just the probability of one plus the probability of other minus the probability of the conjunction, right, of the and of both of them. Now, all these deaths, are mutually exclusive, right? So if you were, if a murder was committed by a handgun, it's not committed by a rifle. If it was committed by a rifle, it's not committed by a shotgun. So what happens is that in all these problems, this and is going to be 0 because these events are mutually exclusive of each other. So it's really just the probability of the murder was committed by a rifle versus plus the probability that it was committed by a shotgun. So we just add the two of those together and we get 6% there. Now interpret this probability. Select the correct choice below and fill in the answers. If 1,000 murders were randomly selected, we would expect about 6% of them to have resulted from a rifle or shotgun. So what's 6% of 1,000? That's just, and here's the work down here, 60 murders. Notice it's not this, because probability never tells you exactly what's going to happen. It tells you what you expect to happen. Okay, so here's just another probability they're asking is, what's the probability that the murder was committed by a handgun, a rifle, or a shotgun? So that's just kind of the last problem with, I think, handguns added on. Okay, so you could just take your last answer and then add on handguns, or I just redid the probabilities. The probability of all these things ORed together is just the probability of each one. Now, that's not very good spelling on shotgun. Now, the whole reason this works, right, is because they're mutually exclusive, so you don't have to subtract out any intersection between them. So this is just this, and this, totaling 53.7%. And again, they asked this, if you had 1,000 murders, how many would you expect to be committed by one of these three? And it's just 1,000 times this, or 537. Okay. And then I think this is the last one, or maybe second to last one. What is the probability that a randomly selected murder resulted from a weapon other than a gun? Now you could almost just do the complement of this answer, except that unknown firearms or some kind of gun. So instead, I just did all the ones on the list that were anything but a gun. So knives, hands, and other. And I just added those three probabilities. Again, they're mutually exclusive, so you just add the probability of each one happening up together. And that's 32%. What's 32% of 1,000? Just 320. So we would expect, right, 320 out of 1,000 murders would result from something other than a gun. Okay, and last one, E, are murders with a shotgun unusual? So you have to remember what our definition of unusual is. At this point, we're going to be allowed to vary this later, but at this point, we're going to say anything less than 5% that happens less than 5% of the time is pretty unusual. So we just look at shotgun and we say, is that less than 5%? Yep. So shotgun murders are given this definition of unusual, right? Whereas handgun deaths are not, right? All right. So I hope that helps a little bit.